the open reading frame. That is, if you have any nucleotide sequence, in that nucleotide sequence you can identify which part of this nucleotide is going to provide the protein. So that is what you can identify as ORF, open reading frame. So for this ORF prediction, we can use different tools like ORF finder in NCBI. Okay, so before going to this ORF prediction, we should have some nucleotide sequence. For that purpose, first we will collect one nucleotide sequence from GenBank. So if anybody wants to provide a name of a protein, I can request the student to give suggestions for the protein name to get the nucleotide sequence. Any one of, so I will take osteopontin. I will take the protein osteopontin. So if you give this osteopontin, you can get this nucleotide, we will go to this nucleotide part and then we will take one nucleotide sequence. Say for example, we can take human osteopontin or chicken osteopontin. We will take this human osteopontin mRNA. Okay, we should take the sequence in FASTA format. So if we sequence any nucleotide sequence by our own procedure or our own research, we can use that sequence. Since we are not having such sequence, we are using already available sequence from the database. Okay, so now I'm going to take this particular nucleotide sequence from the NCBI GenBank database. Now we will use the ORF finder tool. ORF finder from, actually it is available from NCBI. So you can give ORF finder and you can see that ORF finder from this NCBI. So we'll click this. And this is the ORF finder tool, which is going to find out open reading frame. Okay, so now we will give the nucleotide sequence in this box. You can see here, you will provide nucleotide sequence in FASTA format. So now we are going to give the nucleotide sequence in FASTA format here. Then if we have a very large sequence, then we can limit the ORF prediction from 2 options. Okay, so if you want to utilize the whole sequence, you can just give the sequence and then you can leave this as a default condition. That is the genetic code. We will use standard genetic code. Similarly, the minimal ORF length will be like 75 is the default values. Similarly, the initiation codon will be ATG. So these are all left as such. And then now we will give the submit button. Now you can see this ORF prediction is going on. Now we are getting this ORF prediction output. You can see now here the number of ORFs predicted. Here you can see this almost, there are about maximum number is 14. So we will get 14 ORF from the submitted sequence. And the ORFs are represented with plus strand and frame. So the plus means 5' to 3' direction. Of course, frame means in each direction we will have 3 frames. In 5' to 3' direction we will have 3 frames, 1, 2, 3. And in minus, that is 3' to 5' direction we will have 3 frames. So out of the 6 frames, we will get almost 14 ORFs are predicted by this tool. So we can select any one of this ORF. Usually we go for the larger ORF predictions. So you can see this is the larger one, which will give around 300 amino acids. So we will select this ORF. So fortunately here that ORF comes as ORF1, but it may come in anywhere. But in this example, since we took mRNA from the NCBI, we are getting this ORF as a ORF1. But if we use our own sequence, then we might get this ORF anywhere from here. Okay, so now this ORF, so you can see this ORF which is coming out of 5' to 3' strand frame 1. And then the ORF starts from the 109 nucleotide and it stops around 1011 nucleotide. So in between this, there are about 903 nucleotides are there. So if 903 nucleotides are there, then it will give a 300 amino acid as a translated product. So here you can see this. This is the translated product you will get from this particular ORF. If you select another ORF, this sequence will change. So you can see whenever we change the sequence, here you can see the protein sequence changes. And you can also see here, it is also a graphical prediction of ORF. You can see you can select any graphical representation. You can see this ORF changes. See here ORF 12. So ORF 12 is represented in this box. So the larger ORF is ORF 1. You can see here. If you select that ORF, so you can either select from this graphical output or you can select from the tabular form. Anyway, if you select any one of this ORF, here the sequence of that ORF will be represented. So this tool can be used to identify the open reading frame, and with the particular nucleotide sequence from where the translation is going to start and where it is going to end, we can get it, and we can get the protein sequence from that particular ORF. Okay, so this is what the advantage of this ORF prediction tool. So from this tool, we will see the ORF1, and then it will have a maximum number of 300 amino acid. So we can copy this particular sequence and we can note it down the start and stop codons for our purposes. Okay.